Number 19. Find the total number of distinct diagonals that can be drawn from the vertices of a regular decagon. All right, so this is a pretty straightforward formula. So I'll show you the formula and then I'll give you a little bit of intuition for where it comes from. So our formula is if n is the number of sides, so in this case in a decagon n equals 10, then the formula is the number of diagonals equals n times n minus 3 and then divided by 2. So if n is 10, it'll be 10 times 10 minus 3, which is 7, divided by 2, gives you 35. So it's a pretty straightforward question if you know the formula, but this is a little bit of intuition. So let's say you had, I'm going to draw a pentagon, just because I know it's not a decagon, but I'm not confident in my ability to draw a decagon. And pentagon only has 5 sides. So you can think of this kind of as a counting principle question. You know, like you go to a sandwich shop and there's 3 kinds of bread and 4 kinds of meat, then you can make a total of 12 different sandwiches, right? Just 3 times 4. And if you're unfamiliar with that, then go research that on your own and come back to this video, because that's like a whole nother thing. Anyway, the way you can make a diagonal is just by picking the 2 points of the diagonal, which may seem obvious, but look at this. So the first point I pick, I have 5 options for that choice. And there's 5 because you have 5 vertices, which is just the number of sides. So you start with n. And then you have, and then the number of points you can choose for the second part of the diagonal is reduced, right? Because you can't draw a diagonal to one of the adjacent points, and obviously you can't draw it to itself. So you're reducing the number of possible points for the other end of your diagonal by 3. So that's n times n minus 3. So in this case, you would think that since n equals 5, you get 5 times 2 equals 10 diagonals. But if we draw this, and yes, I know this is going to end up being a pentagram. I swear that was by accident. But you can see that this is actually only going to create 5 diagonals. Now, why is that? Well, you can imagine that, say you picked this this point, and then the second point you picked was this one right here. Well, then you would have another diagonal where this is the first point you picked, and then the second one you picked was right here. So you're going to double up, basically. And so this is why you divide by 2 in the end, because you're actually counting each diagonal twice. So the formula is n times n minus 3 divided by 2. So for a decagon, you pick one of the 10 vertices, and then for the second point to make your diagonal, you only have 7 choices now. So 70. And then since you're doubling up, because you could draw like a diagonal from point A to point H, and then also a diagonal from point H to point A. And so you're doubling up, you're counting each diagonal twice. And so you divide it by 2, and that gives you 35 distinct diagonals. We get the same answer as we did before. Alright, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe, and I'll see you next time.